insufficiency, bridging, and solder balling being the primary ones that are detectable. And of course, but where those come from, that's a different question.
When we go down in component size, there's a certain point right around the 0402 component size where suddenly things change, where we have to really pay attention to the powder sizes that we're using. Even the mass thicknesses that we use on our boards become a very important aspect of how we look at our design. So more or less, sometimes we have to really pay attention to the process of what we're trying to build and making sure that all our materials are matching.
Once you've established a process that does work with that particular paste, just assuring that it's within that process window, and that, you know, and the types of things that you can look at are the factors within the solder paste that do affect its viscosity, do affect its rheology, and its ability to either be stressed in a jetting process or be stressed through an actual traditional stencil printing process.
The behavior of solder paste, of course, you're generally taking it from a fridge and then you're using it in a printer. So that material is going to have to shift some 20 degrees centigrade to get from your storage up to your actual operating temperature.
One thing that we have noticed when we're jetting paste, though, is that when you actually have your company at a higher altitude, so if your industry is at a higher altitude, we've seen jetting results different at sea level than if you do it in Denver, for example. Modify cassette models and modify the way that you jet to be able to get the same results using the same material at different altitudes.